Okay, thank you very much. Well, um, as Andrew has clearly made the point, the working group 1 of the and 2 and of the hCOMET included the previous aims of the previous COMET project. And I must say that this has been a tremendous job in which we were able to just, let me say one number. Um, Together with Mirta, we started the beginning of COMET from 500 groups, 500 names that have been working with COMET assay. So from that from that huge amount of names and addresses, we were able to put together about 50 collaborators that contributed their data. And putting together data from different labs to create a combined data set was the first aim of this working group. But let me say that I will be the only one to speak for this working group. And but of course, this work has been shared with Mirta Milic. We have been working together for a long period. She has been twice with a short-term scientific mission in Rome, and of course, she was the one coordinating contacts with different laboratories, and actually making possible the creation of the laboratory of the data set. And the second point, the second aim of the group was actually to make sense of this data. And the idea was just to make sense about the main confounders. What were the confounders that were important to take into account when you design a study on comet assay in human population? So using this data set, we try to make sense of the role of epidemiological and technical predictors, variables that may be important in influencing the outcome. And obviously, we were able to use this amount of data also for the cohort study. That was really a challenging part, as anticipated by Andrew, because actually the idea of validating comet assay as a risk biomarkers is really important for mechanistic, practical, epidemiological, public health purposes. And actually, we were able to create a database, the hCOMET database, that was, and we explored this database that was composed by about 20,000 people. And this is the good news, the good number, but we had also a lot of problems. So we were not really able to address all the questions that we had in mind properly, because of essentially because of variability. I mean, Andrew has anticipated that there are several sources of variation, but just think, even if you start for 20,000 people, once you divide people in samples that are frozen or fresh, when you divide lymphocytes and other that you cannot really put together, when you have 4 different descriptors, I mean, intensity, length, tail moment, or visual scoring. And so it's very difficult. When you start fractionating the results, numbers becomes smaller, and smaller. So that's the reason for which we were not really able to address properly all the questions. But we got some good achievement. And this achievement have been synthesized in this paper. You see, this is the first page of the paper, which is in second revision now in Mutation Research Reviews. And I mean, we are quite positive, and we hope to have positive results quite soon. You see that you have like 100 authors. That means that everybody has collaborated, and the distribution collaborated, and the distribution of countries contributing to this database is really worldwide. And our first idea was to one of the main achievements, the main products of this paper was just to reduce the variability in different laboratory heterogeneity between different labs. One important thing could be what is the most common range of results that you can expect in control subjects. And so this is not an obvious question, because you can see here that on the top is in tail length, tail intensity, tail moment of visual scoring, that there is quite a large variability. However, the idea for us was to identify a range of values which are the most common. You can see here a possibility is the interquartile, so the 50% most commonly results. And so we did this for 3 endpoints, for 3 descriptors, not for visual scoring, because it was too complicated, too heterogeneous, and the results shrinked to very small number. And for each, these slides are from the paper that I anticipated. And you see that for each descriptor, we reported the laboratory, the number, and the mean, the median, and the distribution. So you have an idea of individual laboratory distribution. And we had also, these are based on 8,000 subjects. 4,600 of them were controls. This is the biggest group, which is the one on tail intensity, which was used as the most common the descriptor that has to be preferred. And with a more sophisticated analysis, we were able to identify a range, not only a univariate range, which is based on the percentiles. So for instance, for tail intensity, the most common range of results is between 1.6 and 9.9. Or if you look into controls, it's a little more smaller, in between 1.1 to 6.7. This is supposed to be a range of natural occurring DNA damage, as measured by tail intensity. But we also use what we know from cell type, sample processing, random effect laboratory study, and other to identify some modeled data. So we have also median and mean, which in a way take into consideration the variability introduced by sample processing, cell type, and sex, smoking habit, age, and exposure, which is not, to tell you the truth, is not too different. However, this is an important contribution for all laboratories working in the field. Other results were not so clear-cut, like the role of age, in which this is mostly due to the fact that some laboratory, we cannot really address the variability, because some laboratories working with old people had maybe very low or very high levels. And so this created problems. We tried to model all this amount of data. We were able to find out some kind of trend. So the idea, what is quite clear, that there is a rising trend, and in all descriptors. And in some cases may be really important, maybe doubling the frequency in people in older age classes. And the same is for sex, in which males generally have a higher level than females, even though this could be done to exposure or to higher smoking habit, not completely controlled, but in a way, their answer is that, okay, you design a study, you have to take into consideration both the age and the sex, possibly age by different categories. And we did also a meta-analytic approach that revealed that males and females is a little higher in males, but not that high. In several labs, you don't see any difference. What was clear was that comet assay seems very good in revealing the effect of exposure, because you see here that we put all together laboratories and we have different kind of exposure, but the answer is that, okay, if you want to study an exposure, take into consideration sex, age, and smoking, but the effect is revealed quite clearly. I mean, this paper is going to be published. It's not perfectly what we wanted, especially for technical issues that were not properly addressed. But in a way, it provides a lot of really important information. And we believe it could be a really important contribution, not only to create a big network of people working in the field, to create a network for exchanging information, but provide some reference about especially the frequency, the baseline frequency, but also about the effect of age, sex, and smoking habit. The other part, the final 3 minutes of my presentation is about a cohort study. For a small group of subjects out of the database, which is 2,500 subjects, which is about 25,000 person years from 16 laboratories, they screened people from 1999 and 2019, and overall we were able to identify 308 deaths and 151 incident cancer cases. And so we were able to reproduce the same design, which is an historical cohort analysis, cohort design, and so we were able to identify the risk of, especially of death, depending upon the frequency of the DNA damage measured by the comet assay in healthy people. Well, these are numbers. You see here that we have different laboratories. Some laboratories contributed greatly, like the one in Slovakia or the one by Richard Marcos in Barcelona. And they have some of them have a good contribution in death people. 308 was the overall. Not so good the analysis for cancer incidence, because not many groups were able to identify, to follow up people for cancer using cancer registries. So most of cancer cases come from Spain and Slovakia. So the results are not so exciting in terms of numbers where we expected. I have to run, and I will synthesize the results. I will synthesize the results with one Kaplan-Meier curve. You see here that we have for the tertile of tail intensity, we have stratified subjects in low level of DNA damage, high level, and medium level. And the result of the survival reproduce quite well this distribution. You see that subject with the best survivor were the one with the lowest tertile, whereas people with the highest damage had the worst probability of surviving. This is quite exciting. The results are highly significant. And using the hazard ratio, we were able to calculate in a quantitative manner the hazard ratio, I mean the risk of survival for medium and high tertile as compared with low tertile. And you see that people in the medium tertile has a 24% higher probability of die, And in the highest tertile, this probability reached significance and is 42 times higher than low subjects, so subjects in the lowest tertile. And you see here that if we remove from the causes of death accident, this number raised to 52. So that means that people in the highest tertile has a 50% higher probability of dying. And these results are reproducible for controls in the subgroup of occupationally exposed subjects and in subgroup of patients with some disease. Gastrointestinal cancer was the most the kind of disease. These are I'm talking about cancer now, mortality risk by cancer causes, and we have especially gastrointestinal cancer neoplasms. And as regards non-cancer, you see that disease of the circulatory systems has almost double risk to die for this cause. And the paper has been finished now, is on Andrew's desk for a final English revision, and will be soon circulated among the group for another submission. And these are really, I synthesize very briefly the results. I wanted just to say, to acknowledge those researchers that contributed, that they have done the work to go back to the archives, to extrapolate data, to put it together, to fix it and send it to Mirta and myself. And I want to thank also the volunteers that contributed to our studies, making possible the study, and once more to Mirta, for that has done tremendous work, to Monica Neri as well, that contributed to this part on the Cohort study, and the little kiss to Mirta's wonderful child, Isabella. And that's it. I'm ready to take your questions.
Thank you, Stefano. It really has been a mammoth task, as I said, and I think it's wonderful that you've got such impressive results out of it.
Gudrun just put a question in the chat. On the Cohort study, if the division in tertiles is done per lab?
I mean, the idea of dividing in tertiles is a little bit rough approach. We tried more sophisticated methods, but they didn't work as well. And they were divided because of the idea was to, in this way, you standardize absolute difference between laboratories. I mean, in each laboratory, you have subjects with very high level, the medium and low level. Obviously, it's not perfect, because if one lab is all of them has very high level, is not perfectly overlapping the other, but more or less is overlapping. We had the special problems here because of different descriptors. So we use tail intensity, but we use also tertiles based on a composite endpoint. So we put together tail intensity, and we add also results from tail length and tail moment, considering that you are estimating always DNA damage, and more or less they reproduce the same results because they are highly correlated, different descriptor. I don't know if it was the question posed by Gudrun. Hope so. Anna Silva asked, what kind of occupational exposures were taken into account in the last study? And they are very heterogeneous. And so at the end of the story, we could not, most of them were like ionizing radiation, a lot of pesticides, a lot of, there were studies on nutrition, a lot of studies on patients receiving drugs, chemotherapeutic drugs, no, not chemotherapeutic drugs, sorry, different kind of drugs or different kind of diseases. So we put all of them together, which is just very rough, but to say exposed to some clastogenic events or not.
So if there are no other questions, we'll move on to the next talk, which is by Gunnar Brimborg and Christina Gutskov on Working Group 2.